Hello class, welcome back. Today we're going to get started on section 4.1, right? This week we're going to cover 4.1 and we're going to cover probabilities, right? And some of us are very familiar with this section, right? So I want to go ahead and cover some of the foundation first, right? Whenever we're talking about probabilities. One thing to know is whenever we're talking about probabilities, right, we're going to be dealing with decimals, right? And these decimals must be between 0 and 1, right? So specifically between 0 and +1, meaning you can have 0 as a possible answer, all right? You can have 0.00001, right, as an answer. You can have something else as 0.376, right, as a possible answer for probability. You can have something very, very close to 1, right? So let's just say 0.9999999, right? It's a very, very high probability, right? And you can also have 1 itself, right? You can also have 1 itself. So in other words, your probability or bounds between 0 and 1, right? Including 0 and 1 itself, right? Like we mentioned, they also have to be positive, right? You cannot have a negative probability, right? That's going to be a positive probability. Another thing to know is that you can turn these decimals into percentages, right? You can turn these decimals into percentages. For example, if I were to tell you, hey, I have this advanced hand sanitizer, right, that kills most germs. It's triple action moisturizer, right? And it kills more than 0.9999%. It kills more than 0.9999 of germs, right? Well, if you can give me a percentage, right? You can turn decimals to percentages if you multiply them by 100. If you multiply it by 100, or if you move the decimal to the right 2 times, right? Meaning, for this example, for example A, right, 0.9999 times 100 gives me 99.99%. Very nice, right? Very, very nice. Let's do another example. All right, let's do B, right? Let's do example B and example B, right? There's nothing being displayed here. Let's have the probability, I studied so-and-so these hours, and I believe the probability of me passing this exam is 0.847. We'll do 6, right? Okay, but you want to know what this is in percentages, right? So you're going to multiply this 100 in your calculator, or you can move the decimal to the right twice. So the probability of me passing my exam is 84.76%, right? So in other words, you can have percentages, right? You can have percentages. And it doesn't matter if that value is very small, right? If you multiply it by 100, it's still going to give you a percent. So for example, if you have a very, very, very small value like that, right? And let's just say you multiply this by 100, right? This here is going to give you 0.0234%. It's a very low percentage, right? It's less than 1, but at the end of the day, it's still a percentage, right? If I were to have asked you, hey, I want you to turn this percentage now into a decimal, right? Let's say this is example D, into a decimal, right? So you would do the other way, right? We know whenever we're solving things, right, there's usually a pair. If there's something's being added, you get rid of it by subtracting, right? If there's something being subtracted, you get rid of it by adding. If there's something that's being multiplied, right, it's buddy there, it's going to be a division, right? Meaning that if you went from decimal to percentage and you multiplied from percentage to decimal, you're going to divide by 100, right? So you want to know what 78.34% is as a specific value, as a decimal. I'm going to divide this by 100, right? So this is going to give me 0.7834, right? Now another example would be, let's say, 2.37%, right? I'm going to go ahead and divide this by 100. I'll move this space to the left by twice, right? And you'd find out that it is 0.0237, right? That point is between 0 and 1, right? So one thing we've learned that these values must be bounded between 0 and 1. They must be positive, all right? And you can also use percentages, right? The percentages. And in other words, in percentages, right, in terms of percentages, if we said, right, if we said that these whole numbers must be between 0 and 1 whenever you're looking at them at, non-percentages, in percentage, these must be between what? In terms of percent, these values must be between what and what? 0 and 100%. Right, and that makes sense, right? That makes sense. All right. So let's do a few examples, right, of what is considered and what is not considered, right? Which one of these are considered a probability outcome? 1.41. Is that considered a probability outcome? Yes or no? No, right? This is a no, because that value is not between 0 and 1. It went over 1, so I cannot use that. Let's go to part B. 110%. Is that considered a probability outcome? No, right? No, that's not considered a probability outcome. How about 0? Yes, that works. I can use 0. How about negative 0.82? It's negative, so right off the bat, I cannot. How about 0.66? Yeah, it's positive, and it's bounded between 0 and 1. How about 28%? Yes, very nice. And at any point in this video, right, you want to go ahead and pause it. Go ahead, right? Go ahead. I have here negative 30%. This would be a no. Negative 3/4. It's negative, so no. How about 2/5? 2/5. Well, what I would recommend if you're giving a fraction is plug it into the calculator and find out what this is. This is 0.4. So yes, I can use that. Right? And you need to check, right? Just because it's giving you a fraction doesn't mean it's a number between 0 and 1. So for example, you're given 5/4. Right? This is 1.25, and no, I cannot use that. What about 1? Can I use 1? Yes, I can. Right. Yes, I can. So let's go ahead and move on to the next section. Right. Let's go ahead and give a few examples. Right. Let's go ahead and give a few examples. All right. Go ahead and give a few examples here. Right. I have here the probability that it would rain tomorrow is 0.3. Right. Okay. They give me a decimal. I want to visualize this, right? Because and the reason we're used to visualizing it, right, is because whenever we're checking the weather in our app, in an app or online, right, there's a 50% chance it's gonna rain, right? So we're used to seeing percentages. So if you need to go ahead and view it in percentage, go ahead, right? If you want to know what this is in percent, reset multiply this by 100, and you find out, the probability of it raining tomorrow, it's 30%. That makes sense, right? So what if you wanted to know what is the probability that it would not rain tomorrow? All right. So one thing you can do is the probability that it won't rain, right, is equal to 100% minus the probability that it will rain. It's exactly the opposite, right? And this here is going to be 100% minus, well, we figured out that the probability that it will rain is 30%, meaning the answer is 70%, right? And this is how you solve this numerically, right? And because we know how to do this in our head, right? But as these problems come up, right, in this section, there might be it might be challenging to do this in our heads, plus we need to show our work, right? Right? And another way you can do this, right, if you're not dealing with percentages, right, if they specifically ask you do not use percentages, well, you would use the same formula, right? The probability that it won't rain, right? Well, this is just going to be 1 instead of percent, right? That's going to be 1 minus the probability that it will rain, right? And that it would rain tomorrow. We know that is 0.3, right? And whenever we plug that into our calculator, this gives me 0.7, right? This gives me 0.7. Right, and now to some definitions, all right? We need to go ahead and be able to distinguish between 3 types of probability, right? We have classical probability, that assumes that all outcomes in a sample space are equally likely to occur, okay? They're equally likely to occur. We have empirical, which relies on actual experience, right? On actual data, right? Data taken to determine the likelihood of an outcome, right? And last but not least, we have subjective probability, right? That uses an educated guess or an estimate, right? Based on opinions and exact information to determine the probability of an event, all right? So be sure that we're reading these in our book, all right? That we know the definitions for these, because we are going to have to know this for the exam, right? We are going to have to know this for the exam, right? And let's give a few examples, right? Examples are always nice so we can have an idea of, well, what are we doing, right? What are we doing? So for an example, let's go ahead and make this bigger for you guys. The probability, right? Well, let me go ahead and number these, all right? So you can have something, right? Label these. So for A, the probability that the employment rate will fall next month is 0.03, right? Or 3%. All right, and we said, right, that is based on an educated guess, right, or a calculated prediction, right, and that right there is going to be subjective, right. This here is going to be subjective. For B, what is the probability of getting 4 of a kind when 5 cards are selected at? The probability of getting 4 of a kind when 5 cards are selected at random is 1 out of 4,165. Well, this here, right? This here is classical, right? Where classical, it's a locked pool, right? In other words, whenever you're dealing with a deck of cards, every card that you choose has an equal chance of getting picked, right? So you cannot have more than 52 cards in a deck. All right, so that's locked in, right? That's what I mean by it's a locked pool of choices. And last but not least, right, 383 out of 751 of business graduates were employed in the past. The probability that a particular graduate will be employed in his or her major is 383 over 751, or 0.51 or 51%. All right. That there is going to be empirical, right? Because that's based on experience. That's information based on data that was collected, right? That probability is based on data that was collected. All right. And now we're going to have 2 examples that I'm going to go ahead and give you. And you may go ahead and pause the video and let us know what you think, right? So for example, D, right? The probability that a student will get a C or better in this statistics course is 70%. All right. What is that? Would that be classical, empirical, or subjective? That right there is going to be empirical, right? Because that's based on data that I have gathered from all my previous classes, right? From all my previous statistics courses, right? Let's go ahead and go to part E. The probability that your investment in the cryptocurrency Dogecoin will double next week is 0.0125. Right, that right there will be subjective probability, right, which uses an educated guess or an estimate employing opinions, right, in exact information to determine the probability of an event. All right, so be sure to go through different examples of these until you really lock them down, right? Until we really lock them down in the homework. Okay, and now we're going to be dealing with actual probability, right? The probability of certain events, right? So for example, we're going to be rolling a die, right? In other words, like dice, all right? A die, all right? So, right, we should know what that is, right? If you go to the casino or if you play Monopoly or any board games, right? That's a die, right? How many sides are there to a die, right? How many sides are there in a cube? 6 total sides, right? And we know that, right? We know that these dice go from 1, 2, 3, 4, 5, 6, right? So let's go ahead and find this out, right? What is the probability of, let's go ahead and let's do a pre-example, all right? So that's A, that's B, that's C, that's D, that's E, and that's F. So the first one is going to be the probability of you rolling the dice and it landing on 1. Not one side, but on the actual number 1, right? And how you find this is it's going to be your focus divided by the total number of possible outcomes. Right, so we need to remember this, that in the denominator, it's going to be the total sides. So how many sides are there in the die, right? You know, the total is going to be 6. And on top, it's going to be the focus, right? What are you focused on, right? And that's on a question, right? That is, well, the probability of the number 1 landing is just 1, right? A dice, you know, a 6-sided dice only has the number 1 on one side. So this is going to be 1/6. Right, but we need to go ahead and type it in as a fraction or as a decimal, right? We need to go ahead and learn how to do both, right? And as a decimal, this is going to be to 3 decimal places, right? We have something like this, but I know I got to round, right? I need to go ahead and round to 3 decimal places. So this here is going to be 0.167, all right? 0.167, right? In decimal. And if you wanted to know the percentage of this, right, you would go ahead and multiply that by 100, right? And this here would be 16.7%. All right. Let's go ahead and do number B, right? That's the one that's on the top left corner. What is the probability of getting an even number? All right. So I know that it's still going to be divided by 6, all right? It's still going to be go ahead and divided by 6. And let me go ahead and write out all my options up here, right? Let me go ahead and write up all my available options whenever I'm rolling this die, right? So I can land on number 1, 2, 3, 4, 5, and 6, right? The question was, what is the probability of getting an even number? Well, let's count how many even numbers are there here, right? I have 1, 2, and 3. 3 possible choices. So this here is going to be 3/6, which is 1/2. All right. Well, what goes into both of them? A 3 goes into both of them. And if we plug this into a calculator, this is 0.5. All right. Or if you wanted this in percentages, this is 50%. All right. Very nice. Let's go ahead and do this again. Let's go ahead and do C. What is the probability of not getting an even number? Right. So not getting an even number, that is the same as saying, what is the probability of not getting an even? That's the same thing as saying the probability of getting an odd, right? The probability, in other words, of getting an odd. The probability of getting an odd is 1, 2, 3. Okay, very nice. So this is going to be 3 over 6, which is 1 over 2, which is 0.5, in other words, which is 50%. And you can see this both ways, right? We can see this both ways, right? So in other words, still focusing on C of not getting an even number, right? So that not is very important. So in other words, the probability of not getting, right, not getting an even number, probability of not getting even, that is the same thing as 1 minus the probability of getting an even, right? Not getting an even is equal to 1 minus getting an even, right? So this here would be 1 minus, well, we know that the probability of getting an even, all right, this was from part B, the answer was 0.5. What? And 1 minus 0.5 is 0.5, or 50%, right? Go ahead and go to part D. All right, the probability of getting a number greater than 2, right? So in other words, I want to say a number, the probability of getting a number greater than 2. All right. So as a refresher, right, this is greater than, this is less than, this here is greater than or equal to, greater than and equal to, less than or equal to. All right. So let's go ahead and find numbers that are strictly greater than 2. So in other words, I cannot do 2, so I would start from 3, 4, 5, 6. Very nice. So this here is going to be 4 over 6. Right? These are both divisible by 2. So in other words, this is going to be 2 over 3. Right? If we were to plug this into our calculator, this is 0.667 rounded to 3 decimal places, or 66.7%. Right? And last but not least, let's do E. What is the probability of getting a number greater than 4 and it's an even number? Ooh, so there are 2 things going on, right? So one thing I'm going to want to go ahead and do is focus on the first part, right? Getting a number that's greater than 4. So numbers that are greater than 4, right? Numbers that are greater than 4, not greater than or equal to, strictly greater, are 5 and 6. So I narrowed down my choices, but the other part states, and it is an even number. So it says I can only choose between 5 and 6. Are those both an even number? No, only 6. Only 6s. Meaning that the probability of getting a number greater than 4 and it's an even is 1 over 6. All right, 1 over 6. In other words, this is 0.167 or 16.7%. All right. Right, and we need to go ahead and be careful with that word greater than or equal to. So let's just say, right, let's do another one. What is the probability of getting a number, let's just say less than or equal to 4, and it is odd. Woo, right? Okay, so first let me narrow down that pool, right? And again, I'm using these numbers from on the very top. Let's go ahead and move this over, right? So we can go ahead and have something much larger to look at. Ooh, too large. Okay, right there. So I'm looking at these numbers, right? So let me go ahead and narrow down the numbers that are less than or equal to 4. Less than or equal to, that means I can include 4, 3, 2, and 1. I'm not there yet. I need to make sure that these numbers that I've just narrowed down are also odd, which is just this one and that one. right? So meaning that probability is going to be 2 over the total amount, which is 6, right? And this is 1 over 3, right? And what is 1 over 3, right? What is 1 over 3? This is going to be 0.333 or 33.3%. Okay. So now we are going to be dealing with 2 dice, right? With 2 dice, all right? And so for an example like this, I am going to provide this table in the exam. All right, you will not have to memorize this table, but I want to know ahead. I want to go ahead and find out how to read this table. All right, how to read this table. So I want to know if 2 dice are rolled one time, right? One time each. Find the probability of getting a sum of 10, right? A sum of 10. So in other words, a sum of 10, all right? So for example, let's look at this table. So let's just say, before we get to that one, right? Let's say that you rolled the first die, right? The first die, and it landed on a 2. All right, you rolled the second die and it landed on a 3. The sum of those, all right, the sum of those right there, where this row and this column intersect, is going to be 2 comma 3, which is, if you get the sum of those values, right, 2 plus 3, this is going to give me 5. Right, this is going to give me 5. Right, so let's just say you want to know the sum, right? You get the first die and it lands on a 6. You get the next die, and it lands on a 2. All right, you're going to go look where they both intersect. The sum of those 2 dies is going to be 6 plus 2, which is going to be 8, right? Going to be 8. And last but not least, you want to know what is the sum if your first die lands on a 4 and the other one lands on a 6. All right. The probability of that happening, not probability, but the sum of those would be 4 plus 6, which is equals to 10. Right. So they're, these are all the possible outcomes. These are all the outcomes, right? And if you count these, right, you can count each piece individually, or you can go ahead and do 6 by 6. You'll see that there are 36 total possible outcomes. Regardless of how you roll your dice, the total number of possibilities are always going to be no more than 36. All right. So with that being said, right, if 2 dice are rolled one time, find the probability of the sum being 10. Right. So in other words, how many ways can you get your die to be a sum of 10? Right. So in other words, I'm going to go through this list and find out which of these numbers adds up to 10. All right. I know it's 6 and 4, right? 4 and 6, right? And this is symmetrical. So one landing on 6 and the other one on 4 is one of them. What's another way you can get 10? All right, you can't say something like 7 and 3, right? 7 plus 3, sure, that gives me 10. But remember, these die only have go up to 6, right? But 5 and 5 do, right? 5 and 5 do. All right, so that means the probability of you rolling a die and landing on getting a sum of 10 is going to be a total of 3 over 36, right? 3 over 36. You want to know what this is in decimal form. This here is 0.083. All right, so this here was my columns for 10, right? And you'll see a pattern with these, right? If I were to have asked you, find the probability, right, that you roll these dice and they land with a sum of 9, all right, with a sum of 9. Well, 3 plus 6 gives me 9, so that's 6 plus 3. 5 plus 4 gives me 9. And 4 plus 5 gives me 9. So if you notice, they are on this diagonal line. So that is going to be 4 over 36, right? 4 over 36, which is 0.111, right? Or 11.1%, right? What is the probability that your sum lands on 11? What is the probability of 11? Well, 11 can only happen 2 times, right? In other words, it's going to be 2 over 36, right? 2 over 36, which is 0.056 or 5.6%. All right. Let's continue with the examples that I had given us here on the board. All right. Now that we did some pre-examples, right? So we did the probability of the sum being a 10, right? Let's go ahead and find out what's the next one, right? I have here, find the probability of getting a sum of 9, right? Or a sum of 5, right? Sum 9 or sum of 5. So let's count these. Let's focus on the sum of 9s first, right? We said these are 9s, right? All these there. And landing on a 5, right? Well, that's going to be 4 plus 1, 3 plus 2, 2 plus 3, and 1 plus 4. So it's going to be that diagonal right there, right? And since this is an OR statement, right, I'm going to go ahead and add these up together. That is 4 plus 4, right? So for B, it is 4 plus 4 divided by my 36, right, which is 8 over 36, right? And what is that in decimal? This is 0.2222, right? Or 22.22%, right? Right. What is the probability of getting doubles? All right, so you want doubles. So that means the one die lands on 1, the other one dies. The other one lands on also a 1, or one lands on a 5, and the other one lands on a 5, right? So we're looking for twins, and this happens here. All right, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? How many out are those? That is 6 over my total possible outcomes, all right? And 6 over 36, right? This is going to give me 0.167, right? Or 16.7%. And last but not least, the sum being greater than or equal to 5. Ooh, okay. So the probability of the sum being greater than or equal to 5 is everything that is 5 itself or greater than. All right. So if we count these, right, that is 3 by 6 on this first part, right? 3 by 6, that gives me 18, right? 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, right? That goes ahead and gives me 30 over 36, right? If you plug this into a calculator, all right, this is 0.833 or 83.3%, right? And one thing you'll go ahead and notice that whenever you're doing these is that sometimes they might be able to find the alternative, right? So if I had ever asked you, right, I want you to give me the probability of choosing a number that's greater than or equal to 5, right? The sum is greater than or equal to 5. This is the same thing as saying, right, the probability of this happening is the same thing as 1 minus the probability of x less than 5, right? The probability of you choosing a number less than 5, right? So the probability of choosing a number that's less, the sum is being less than 5, right? Not less than or equal to. So that means it's going to be any sums that are 4, 3s, and 2s, all right? And that happens here, right? And I mean, and if you look at that, right, that's much easier to count than counting that larger part, right? That right there is 1, 2, 3, 4, 5, 6. So it's going to be 6 over 36, right? Right, we know 6 over 36, right? So this is 1 minus 0.167, right? Subtracting that one from 1 minus 0.167, that is 0.833 or 83.3%, right? We solved it the other way, right? Where it was 30 over 36, and that's what it gave us. So different approaches, right? And these approaches come very handy, especially during exams, right? Or whenever you're dealing, well, with very large data, right? So let's go ahead and continue to the next problem. All right. So we're going to be dealing with cards now, right? We're going to go ahead and be dealing with cards. Right, a deck of cards, right? So one thing to know is I will not provide this table for you in the exam. You must, this information you must know, you must memorize. So not memorize, you just have to know, all right? I want you to go beyond memorization, right? And just knowing, right? And like I've said before, if you're driving, you don't memorize how to drive, you know how to drive, right? At first, sure, you memorize it, but then you go beyond that. And that's what I want us to do. I want us to go beyond memorization, where you just know these things, and then you don't struggle with memorization, right? Because you just know it, right? So there are 52 cards in a deck, right? There are 52 cards in a standard deck of cards. Furthermore, right, there are 26 red cards, and there are 26 black cards. Right, there are 4 different categories, right? There are 4 different suites, right? You got the hearts, you got the diamonds, you got the spades, and you got the clubs, right? And even furthermore, right, you have 13 of each suite, right? So you have 13 hearts, you have 13 diamonds, you have 13 spades, and you have 13 clubs, right? And we can see that here, right, labeled, right? You have your ace, then you have your 2 all the way up to 10. You have your jack, your queen, and your king, all right? And what would be the total? What would be the total here when you're dealing with a deck of cards? 52, all right? This is the total number of cards you can get from your deck, right? So let's go ahead and begin, all right? So we want to go ahead and know if one card is drawn from the deck, right? If one card is drawn from the deck, find the probability of you getting an 8, right? So you're going to go here. You're going to know how many 8s are there in a deck of cards. Right, there's 4 of them. Right, there's 4 of them. Right, of it landing on an 8. So that there's going to be, for A, it's going to be 4 over 52. All right. And you plug this into a calculator, all right, I get 0.077 or 7.7%, right? B, the probability of you picking a 6 and a spade, all right? The probability of picking a 6 and a spade, right? So you're only drawing 1. Remember, you're only drawing 1. So I'm going to go ahead and find where these intersects. So the probability of finding a 6, but that it is a spade, right, is just 1 card. That can only happen once. That's going to be 1 over 52, right? 1 over 52. This is 0.019, right? Or in other words, this is 1.9%, right? Oops, what did I do? Very nice. And for this last part, right, I have here the probability of getting a 3 or a club. Right, the probability of getting a 3 or a club. So the chances I can get a 3 are 4, and the chances that I can get a club are 13, right? Because it's or, so right, it's one or the other, right? You know, it's one or the other, right? But you need to be careful here, right? We need to go ahead and be very, very careful here, because you need to make sure that you do not count twice, right? That you do not count twice. So in other words, what I mean by that is, since it is not an and statement, right? It is not an and statement. The probability of me getting a 3 is 4. The probability of me getting a spade is 13, but I'm going to subtract by 1, or else I'm going to be counting the 3 of spades twice, right? I'm going to take them into consideration twice. So I'm going to go ahead and subtract by 1, right? Over 52. And you need to remember this. This is when you're drawing one card and it's an or statement, right? So whenever they intersect. So you go ahead and add these together, right? You get 16 over 52, right? And 16 over 52, this is going to give me 0.308 or 30.8%, right? Go ahead and give another example. I want to know the probability, we'll call this D, right? You want to go to the probability of drawing a heart or diamond, right? So I'm going to go ahead and highlight my hearts. How many hearts can I possibly get? I can get 13. The probability of me getting a diamond, right, are again 13 options. They don't intersect, right? These two do not intersect. So I'm not counting these twice, right? So I do not have to subtract by 1. So in other words, this is going to be 13 plus 13 divided by my total amount, which is 26 over 52, which is 1 over 2, which is 0.5, is 50%, right? So let's be careful, right, whenever we're dealing with these cards. Okay, now we're going to go ahead and move on to a word problem, right? So in other words, some of this information you're going to have to dissect, right? So a shopping mall has set up a promotion as follows, right? You go to the Galleria Mall, right? And you usually have these games, right, where you can win like a gift card or something. You spin the wheel and the wheel lands on a specific number, right? A shopping mall has set up a promotion as follows. With any mall purchase of $100 or more, a customer gets to spin the wheel shown here, right? If the number 1 comes up, right, you can get a, you can win $20, right? If the number 2 comes up, right, the customer wins $10, right? If the number 3 or 4 comes up, 3 or 4, right, the customer wins a discounted coupon. So you get a coupon, right? So one thing I'm going to want to go ahead and do, right, is now that I found out what the 1, 2, and 3 or 4 stand for, I'm going to find out how many of these do I have in my wheel, right? How many of these do I have in my wheel? So let me go ahead and count the ones that I have. All right, so I have 1, 2, 3, 4. So in other words, my n is equal to 4. All right, let's see how many 2s that we get. I got 1, 2, 3, 4. All I count is 4. And how many times do I see a 3 or a 4? So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So one thing that I want to get is, what is my total options, right? I'm going to be dealing with a fraction here eventually, all right? I'm going to be dividing these by a certain number. In other words, you're going to add these frequencies. It's 4 plus 4 plus 12. So there, in other words, a total of 20 outcomes, right? There's a total of 20 outcomes, all right? And it's very helpful to label these, because as you're answering each question, I don't want you to go in and start counting each one, like 1, 2, 3. Okay, that was 1. Okay, you know what I mean? Just do it once, have these labeled out, and it's going to save us so much time whenever you're doing the homework and whenever you're on the test, right? So question number 1. What is the probability of a customer winning $20? Right? What's the probability of winning $20? Well, the times that you can get a $20, that's how many number ones were in that wheel, and that was 4 out of 20, right? And this here is going to be 4 over, right? 4 over 20 was going to give me 1 over 5, right? Which is 0.2, right? Or 20%. So chances are pretty low, all right? There are pretty low chances of getting $20, right? Okay, let's do B. What is the probability that the customer wins money? Okay, so in other words, now that you've written everything down, how many times can you get money? Well, I know if you land on a 1 and on a 2, or on a 2, that's where you can get money, right? So how many of those do I have? That is going to be 4 plus 4 over 20, which is 8 over 20, all right? So 8 over 20 is going to be 0.4, or 40%, right? So the probability of you spinning the wheel and getting cash out of it is 40%, all right? So what do you think is the probability of winning a coupon, right? And some of you might be able to see it already, but if you don't, that's okay. Just compute it, all right? Right? The probability of getting a coupon is, how many ways can I get a coupon? That is going to be 12, right, over 20, right? We go ahead and plug in 12 over 20. This is going to be 0.6, or 60%, right? And we know that probability of winning a coupon can also be written as 1 minus not winning a coupon, right? And the probability of not, what does not winning a coupon mean? Well, that just means winning cash, winning money, right? And you already know that. We knew that, right? That was part B. The probability of you winning money was 0.4, right? So 1 minus 0.4 gives me 0.6, or 60%, which was exactly what we had found there, right? So there's always 2 ways you can solve these problems, right? There's always 2 ways you can solve these. All right, let's go ahead and move on, continue with empirical probability, right? Well, we've said, right, this is the formula there, right? Which is the frequency for a class, right? Your focus, right, is the frequency for your class over the total amount, right? Over the total number of frequencies, right? So for this example here, you got rural speed limits. Rural speed limits for some states are indicated below, right? 60 miles per hour once, 65 miles per hour is 11 states, 70 miles per hour is 16 states, and 75 miles per hour are in 12 states, all right? So let's just say you're going to choose a state at random. Find the probability that its speed is 60 or 65 miles per hour. So, well, one thing I want to find out first is my total, right? My total, and that's going to be my frequencies, right? For each one. So this is going to be 1 plus 11 plus 16 plus 12, right? These are my total options, right? So this is 1 plus 11 plus 16 plus 12, right? This is going to be 40, all right? And so we said the probability of getting a 60 or 65, right? So the probability of me getting a 60 is going to be 1. And then the probability of me getting a 65 is going to be 11. So I'm going to add those two. This is 12 over 40. Right? This gives me 0.3 or 30%. Very nice. You want to know the probability of getting something that is greater than 65 miles per hour. Are you going to include 65? No, right? Because if I had said greater than or equal to 65, you would include 65. So in other words, you just want everything greater than 65, which is going to be those two classes right there, which is going to be 16 plus 12 over my total, which is 40. Right? This is going to be 28 over 40. And what is that on our calculator, right? Right, that gives me 0.7 or 70%. And last but not least, right, what is the probability of choosing a state at random and it being 70 miles per hour or less? So it is 70 miles per hour or less, all right? So in other words, I'm going to include 70 and anything below it, right? The wording there where there's different than B, all right? So I can include 70 and anything below it, and that's going to be 1 plus 11 plus 16 over 40, right? And that is going to be 28 over 40, right? Which is going to be 0.7, 70%, all right? Very, very nice. Let's go ahead and continue with the next problem. Right, during motor vehicle accidents, during a recent year, there were 11.2 million automobile accidents, 8.4 million truck accidents, and 171,000 motorcycle accidents. Find the following probabilities, right? Well, one thing you may want to do is count total accidents, right? The total accidents. And right, one thing you can, how you can approach is 11.2 million. That is just 11,200,000, right? 8.4 million is 8,400,000. And once 171,000 is just 171,000, right? So you can go ahead and add all of these up. Another way you can see this, which is going to be quite helpful, right, is if I'm just dealing with millions, right? If I'm just dealing with the unit millions, right? If I know that every value I plug in is millions, right? So I can have 11.2 million, 8.4 million, all right? And, all right, give me 1 second here. All right, let's use this table that I got here, right? So, because I want you all to actually know how I'm getting these values, right? Let's go ahead and pull this table out, right? Like we said, I only want to be dealing in millions, all right? Because it's going to be, the reason I want to count numbers in millions because it's going to be much nicer whenever I'm plugging these in, right? If I'm just talking about millions, then there's going to be no reason for me to plug in all those zeros all the time, right? So if I'm just focused on the numerical value millions, I'm going to get this value and I'm going to divide this by a million, right? And when you plug that in, what do you get? Oh, 11.2, okay. You plug in the other one, what do you get? Right, you get 8,400,000 and you divide it by a million, right? It gives us that. Okay, right. So some of us might have been thinking, how do you write 171,000 in million? Well, you do the same thing. You get 171,000 and you divide this by a million, right? A million has, so we know, 6 zeros, right? If you go ahead and plug this in, it just gives me 0.171 million, All right. So that's much nicer, right? So now I'm only going to be talking about millions and just using these values, right? I'm going to just be using these values instead. No reason to plug in all those zeros, right? So the total of number of accidents, right? My total, right, is 11.2 plus 8.4 plus 0.171, right? So the total, that denominator, right, that's going to be in all of them. I'm going to add all those up together, 0.171. I get 19.771. All right. And if you were to have added these manually, right, you'd see that, right, that this is just 19,771,000. All right. But I don't need to plug in all those zeros, right? I need to go ahead and plug in all the zeros in. I'm just talking about millions, right? So find the probability if one accident is selected at random. Find the probability that it's either a truck or a motorcycle. All right. So the probability of me landing on a truck in terms of million is 8.4. And the probability of me landing on a motorcycle is 0.171 over my total amount. All right. And what does that give me? Here, this gives me 8.571 divided by 19.771, which is 0.434 or 43.4%, right? And remember, whenever you're solving any of these for this section, since we're dealing with probability, we know we're on the right track because all these values, right? If you're looking at it in this decimal form, that number must be between 0 and 1. Or if you're looking at it in percentage, right? It has to be between 0 and 100%. All right. So if for some reason you get 433%, something's off, right? We might want to check that, right? So and for part B, right? What is the probability if one accident is selected at random? Find the probability that it's not a truck, right? The probability of it not being a truck, right? So which one of these are not a truck? Automobile's not a truck, and motorcycles are not a truck, right? So in other words, I'm just going to be focused on those, right? This is going to be 11.2 plus 0.171 over my total, 19.771, right? If we were to go ahead and compute these, this would be 11.371 over 19.771, and this here would be 0.575 or 57.5%, right? And since it was a not statement, right, there's another way you can solve this is 1 minus the probability that it is a truck accident, right? That it is a truck. So the probability that it is a truck is 8.4, right, over my total, right? And 8.4 divided by 19.771, right? This is 0.425, right? And 1 minus 0.425, what does that give me? This gives me 0.575 or 57.5%. And hey, look at that. It's this give us the same value, right? And it's always going to give you the same value, right? So let's get used to learning how to solve this both ways, because as we continue with these sections, it's going to be very helpful to do the 1 minus option. All right, it's going to be the 1 minus option. So thank you very much for your time, and I'll go ahead and be seeing you in section 4.2. Thank you.